All right, it says each of 7 judges voted for or else against granting Datalog Corporation's petition. In other words, we have 7 judges and they're either going to go for or against. This sounds like a grouping game, and it sounds like a special type of grouping game, which some people call in-out games, because there's an in-group and an out-group. Here it's a for or against. But in any case, in-out games are just grouping games that have only 2 groups. And we were just talking about the asshole rule, remember? If you have 2 people and they can't be together for some reason because they don't like each other, in a 2-group game, in other words, in an in-out game, those rules are really nice because you just separate those 2 people, one in one group and one in the other. And that happens a lot in in-out games. Also, in in-out games, because people can only go in one group or another, there's only 2 options for every individual, every variable, right? Which means you can almost always create worlds on the basis of one of those people, right? You say, well, this person looks important. Let me put them in one world and out in the other world and see what happens. All right, in any case, here we have 2 judges are conservative, 2 are moderate, 3 are liberal. This is like LSAC's aspirations, right? They're like, this would be a nice Supreme Court, but they don't always get what they want. Has anyone studied for the GMAT? I picked up the GMAT like 3 years ago, and I did a reading comprehension section, and it was all about how some big company came into this small town and really turned around the economy. And I remember I was like, what's wrong with this passage? Like, it just doesn't seem like everything I read on the LSAT. So anyways, you have different business school, whatever. Okay, so if the 2 conservatives and at least 1 liberal voted the same way as each other, then both moderates voted that way. Wow. Okay, so if we have 2 conservatives and at least 1 liberal, I'm just going to write the 1L, because as long as I have that L, that rule applies. If I have more than that, it doesn't matter. So I'm not going to worry about that situation. Then we're going to have 2 moderates in that same group. Sound good? Question? Okay. Then it says if 3 liberals voted the same way as each other, then no conservative voted that way. Okay, so if I have 3 L's together, then I can't have any conservatives, right? No conservatives in that group. Yeah.
When we're doing the if rules for grouping games,
Yeah.
we're always going to rate them vertically, right?
Well, because this if-then statement is like a grouping thing, it's saying it's in the same group,
Yeah.
then that's how I would write it. Sometimes they might say something like, if a liberal voted here, then a conservative voted here, then I would probably just write it like that. So it wouldn't be vertical, it would be horizontal.
But wouldn't you do like if L, 0, not, whatever, C? Does everyone use that?
Well, because we have 2 C's in this game, you could, if it said if L then C, the other C could still be here. It's just saying that if you have a liberal voting here, you have to have at least 1 conservative over there. So it wouldn't necessarily be the case that if you have L, you don't have C.
Oh, gotcha. Okay.
Yeah. So yeah, it just kind of depends on the rules. But these 2 rules in particular, we're talking about the same group, right? This room is getting cool. You're like, we have escaped the winter vortex. No, you gotta go to LSAT class. At least 2 of the judges voted for D, and at least 2 voted against. So in my in group, I have to have at least 2. In my out group, I have to have at least 2. Okay. Then it says at least 1 conservative voted against. So I'm going to put that C over here. I'm also going to cross that out. If you wrote C2, M2, L3, you're making this more like math. I just want to see the pieces and deal with them, right? And so that's why I'm going to write them out. Okay, that's all the rules. Now, given the fact that we were told something about C, and we were told that C goes in the outgroup, right? I thought to myself, aha, there's only 1 C left, right? And if C goes here, that means that last C, right, is either going to go out or in. It's either going to go against or for. And if it goes for, what rule disappears?
First, if all three L's are together, then
First,
FC.
if.
Yeah. Okay. So this rule actually it doesn't disappear. We have to worry about it, right? But it does mean that none of the L's are gonna. You can't have all three together because if C is over here, then you can't ever have all threes together. All three L's together, right? So that's significant. This rule right here goes away, right? Because this rule says if you have the two C's and an L, then you have to have two M's. I'm like, I have two rules in this game, and if the two C's are separated, I don't have to process that rule ever again, at least in that world, right? Now over here, if C is in, then this rule still applies, but it's only going to apply to this group, right? So it's sort of like, oh, okay, this seems like this could be beneficial. So what I did is I said, let's create one world where C is in and one world where C is out. So this is C, C. Either C is going to be in or both C's are going to be out, right? Now, for this one, like what we were just talking about, if all three L's are together, then you can't have C. That's going to be problematic in both of these. So what does that mean? If you can't have all three L's together, what must be true? Yes? Both has at least one, right? That's what we're trying to figure out is what must always be true. If you can't have them all together, then you've got to have at least one over here and at least one over there. You guys okay with that? Okay. Now, you guys remember the question you can ask yourself as you're trying to make inferences? What's left, right? So what is left at this point over here? Two M's and an L, right? Now, sometimes it's like, well, I got two M's and an L. I don't know where they go. The way to decide whether you're done making inferences is to look at the rules and see which rules still apply. So, is this rule ever going to get triggered in this world? No. Nope. Is this rule ever going to get triggered in this world? Nope. So the rules are done. Which means the three remaining variables, L, M, M, must be what? Floaters. So this world is basically L, M, M, and they can go anywhere. And I wrote them down here so that I can mentally move them around, right? Like I could put them all on one side or all on the other or split up however I want. Okay, let's go over here. At this point, this rule still applies. So if you have two C's over here, I can't put all three L's over here. So what does that mean must be true? At least
one L.
At least one L.
At least one L has to be 4, right? Because if I put one L over here, then this rule is never going to get violated. Now I don't have to worry about that rule anymore. Right? That rule is gone. Now we still have this rule right here. My desire is to get rid of it, right? So I never have to process it again. Does anyone have a suggestion as to how we could get rid of it? Yes?
I guess break it up into one more set of rules, one where that's the case and one where it's not.
Yeah, either have L here, right? One more L here, or have both L's over here. Because either you're going to have one more L or you're not. You're either going to have at least one more or you're not going to have any more. So I'm creating two worlds, one where L is over here and one where there is no more L. Oh, shoot. Okay, I got to give myself a little more space here. 1, 2... Okay, so either L is going to be over there, or it's not, which means it's all over here. Are you guys okay with that split? Anyone confused? Yes?
Sorry, can you repeat why you said the L goes or something?
Oh, why? There has to be an L up here?
Yeah.
Okay, so I initially put that L up there because when you have two C's, right, I can't have all three L's there. Because if I have all three L's, then I can't have a C. So that means at least one of the L's has to go over here. But so that rule is done. Now I still have this rule, and I'm thinking to myself, well, either the rule is going to get triggered, and because I have an L here, at least one L, or I don't have at least one, which means I have none. So they all go over here, right? So that's the world where they all go over here. Let's talk about this world for a second, because it's got 5 of the 7 variables. Do we care about this rule anymore? Nope, it's never going to be violated because we have 3 L's together, but we're not going to have C's because they're over here. Do we care about this rule? Nope. So that means the remaining variables are floaters, right? So this is going to be M and M. They can go anywhere. These guys can go anywhere. Now here, this is nice. If you have CCL, at least one L, what do you know? You have 2 more M's, right? So I got to put these 2 M's over here. Who's left at this point? One more L. Now, I just said that there was at least one L over here, but I actually can't put any more L's over there because I still have to put an L over here. You guys okay with that? I'm going to split this up so that it's a little easier to see. I don't know if that helped at all, but okay, these are our 3 worlds. That's it. That's how this game is played. Now, it may seem like there's a lot of scenarios, but how many scenarios are here? 1, right? How many scenarios are here? There's actually 3. So you either put all the M's over there, right? That's 1. All the M's over here, that's 2. Or split them up. That's it. So there's 3 here. Can anyone figure out how many are here? Little mental gymnastics. I hear a vote for 6. Is that right? Anyone else have another number? Focus in on L for a second. You can always split this. If L goes on this side, how many options are there?
3.
3, right? It's the same thing with the M. Either all the M's go over here, all the M's go over there, or they get split. That's 3, right? Or you put L over here, and you do the same thing again. All M's over here, all M's over there, all M split. All M split? Anyways. That's 3 and 3. So we have 6, 1, and 3. That's 10. There's only 10 ways this game can go down. Okay, cool. Now, I know you don't care about this stuff, but or maybe you do. I don't know if you care or not, but I was curious. Oh, sorry, really quick.
I'm sorry, I just have one question. In
Yeah.
scenario 2, why is it that it has to be LL? 4, why can't it be LM?
Oh, right there.
Yeah.
Oh, because if you have CCL, then you have to have the 2 M's here.
Can we have 2 C's, 2 L's, and then 1 L for?
Like do CCLL
Mm-hmm.
and then M. Well, this rule was if you have 2 C's and at least 1 L, as soon as you have that 1 L, you now have to bring in the 2
At
L's.
least, okay.
You
Yeah.
have another L because it says at least 2 voted for and 2 voted against.
Yep, and at least 2 on each side rule is going to pull that other L over. Like right now, if I say CCL, then I know I have to have 2 M's. I could have another L, except for the fact that I need to put something over there.
Okay.
Yeah. Is that cleared up?
Yeah.
Cool. All right. So I was just curious, once these worlds are done, how long does it take to do the questions? 54 seconds. No joke. I was like, hey, let's see how this goes. So, let's see. I'll try not to do it in 54 seconds because a lot of that's, in your head, but we can do this pretty fast. If the 2 moderates did not vote the same way as each other, okay, if they don't vote the same way as each other, what worlds am I in? 1 and 3, right? And they're just separated. They're just split. Which I find could be true. Could you have no conservative and exactly 2 liberals voting for? Here you have a conservative, and here you have 3 liberals, right? That's not going to work. Exactly 1 conservative and exactly 1 liberal voted for D. Okay, could
Yep.
yeah, right here. You split the M's and you take this other L and you throw it over there, right? That could be true. So that's the answer. 14, which one of mine must be true? Must be true means it's always true in all of our worlds, right? Does it always have to be true that there's at least 1 conservative voting for? Not in this world and not in this world, right? You could have no conservatives voting for in both of those worlds. At least 1 liberal voted against. Yes, yes, no, right? So that does not have to be true. At least 1 liberal voted for. Yes, 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 in every world there's at least one L voting for, so that's got to be the answer. 15. If 3 liberals all voted the same way, what world are we in? 3. This is the only world in which that happens. Which of the following must be true? We can actually predict the answer. What has to be true in this world?
All conservatives are against.
Yeah, both conservatives are against, right? So I'd actually scan for that. Oh, they don't have that. They have one conservative, and that's messed up. But they do say all three liberals voted for. So yeah, that's got to be true. And not my prediction. But in any case, 16. If exactly 2 judges voted against, which one of five must be true? If exactly 2 voted against, we're in this world and this world. And what's got to be true in both of these worlds?
The floaters goes to.
All the floaters come over here, right? So that means L, M, M, and MM all come over to 4. What's true about both of those worlds?
At least one moderates are on the same side.
Both moderates voted for.
Both like I'm seeing that the moderates floated over here, right? So I'm thinking, okay, the moderates have got to be voting for. What does it say? Which of mine must be true? Both moderates voted for. That's not surprising, given that was the inference that came from that initial assumption, right? Okay, so the answer is A for 16. 17. Each of the following could be a complete and accurate list of those judges who voted for, except. So we're looking. So if they did vote for, if this is a complete and accurate list, then it's wrong. So could you have 2 liberals? Yes, you could, right? Okay. Could you have 1 conservative and 1 liberal? Yes, we have that here. Could you have 2 moderates and 3 liberals? 2 moderates and 3 liberals. Yes, we could here, right? Okay. Could you have 1 conservative, 2 moderates, 2 liberals? 2 moderates, 2 liberals. 1 conservative, 2 moderates, 2 liberals. That works right here. Okay, so it must be the last one. 1 conservative, 2 moderates, 3 liberals. Yeah, if you have 3 liberals, then your conservatives are over here, right? Okay, 18. If the 2 conservatives voted the same way as each other, but the liberals did not all vote the same way, which of mine must be true? If 2 conservatives are together, so we're not here, and the 3 liberals are not together, so not here, we're here, right? Sound good? So, what has to be true? Oh yeah, question?
Can we go back to 17
Sure.
for a quick second? I just want to know if the way I did this one was wrong.
Sure.
I picked E because it added up to 6, and neither of the 2 sides could be 6.
That's totally
But is
fine.
that
Yeah.
definitely
Anyway,
wrong?
yeah. There's
Okay.
multiple ways to the top of the mountain.
Okay, it almost seemed like too simple, so I wanted to know if that was like a
No,
bad way of
that
thinking
totally
about
works.
it.
Yeah, because you got 2 and 2, so you got at most 5, right, for any group. Excellent. Okay, 18. If the 2 conservatives voted the same, okay, oh yeah, so we're in here, we're in World 2. Each of the following must be true except. So A, both conservative voted against. Yes, that must be true, so that's wrong. Both moderates voted for. No, actually they both voted against. So that is something that must be false. That's the answer. Yes?
Could you put number 16 and how you got the answer?
Sure. If exactly 2 judges voted against. So if exactly 2 are in the outgroup, I could be in this world or this world, right? What happens in these 2 worlds if exactly 2 are out? Do you see stuff happening?
Oh, then everyone has to go over to the.
Everybody's got to
Okay.
float over here, right? And so that's going to put the 2 moderates over in the 4 side in both worlds. And so when it says must be true, both moderates voted for, yes, that's the answer. Any other questions on this game? Okay, did anyone get, sorry, I forgot to ask, did anyone get 10 for the number of possible scenarios? Yes, yes, yes. Okay, great. That's that.